So why do we discuss scope when we discuss our introduction to control structures? In many languages, control structures define the scope. A single variable usually lives within a control structure's definition, and once the computer leaves that control structure, the variable is lost. This is especially true in most languages for conditionals and loops. The inside of a conditional can see variables that were defined before the conditional, but the code that runs after the conditional can't see any variables that were created inside of it. Why is this? The reason is that the computer can't guarantee that the contents of a conditional statement actually ran. If you create a variable called myVariable inside some conditional, then the code outside the conditional doesn't know that the line of code creating myVariable was ever run. That means myVariable might not actually exist. But this only applies to variables created inside the conditional. If a variable was created before the conditional, it can be referenced both inside and after the conditional. Functions define scope even more narrowly. A function's scope is generally just the variables sent to it or created within it. Functions don't automatically see anything created before they're run. They only see those things that are sent into them intentionally. Functions can see some variables that are defined even more globally. It's possible to define variables in a way that forces them to be visible everywhere in the program. But for now, we'll focus on the more natural forms of scope.